10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff.
Vehicles clear.
Stage 1 propulsion is nominal.
High voltage battery discharge, nominal.
Our 28th Electron launch vehicle has successfully lifted off the pad and is on its way to space. Before it gets there, it has a number of critical milestones to pass through, the first of which is called Max Q. Max Q is the first test in Electron's journey, where it experiences maximum aerodynamic pressure, or where the forces on the rocket are at their peak.
Past Max Q.
Nice.
There's the call. Mission Control has reported Electron has successfully passed through Max Q, its first milestone after lifting off from the east coast of New Zealand. The 9 Rutherford engines on Electron's first stage are performing well, and we're ready for the next series of milestones in the launch process.
Up next is main engine cutoff, known as MECO, which immediately precedes Stage 1 separation. MECO allows the vehicle to decelerate slightly before the first stage separates from the second stage. As the first stage falls back to Earth, the single space-optimized Rutherford engine on the second stage ignites to take the vehicle, with payload, the rest of the way into space. You'll see both events on screen, and we should hear Mission Control confirm from vehicle telemetry.
Stage 1 propulsion holding nominal. Standby for MECO in around 30 seconds.
High voltage battery discharge, nominal.
Entered burnout detect mode.
MECO confirm.
Stage separation successful.
And stage ignition.
You can see on your screen that Electron's first and second stages have successfully separated. The single space-optimized Rutherford engine on Electron's second stage is glowing red as the nozzle radiates heat from the exhaust. Because the vehicle has now cleared the majority of Earth's atmosphere, we can get rid of the payload fairing to shed some extra weight. We should see that on our screens shortly.
Fairing jettison succeeded.
Stage 2 propulsion is
And there it
nominal.
is. You can hear the payload fairing tumbling away on your screens now. The NRO payload is now exposed to space in preparation for payload deployment later in the mission.
This fairing will burn up as it re-enters the atmosphere, while the second stage continues on. If you're just joining us, we've had a successful start to Electron's 28th flight. The vehicle cleared Pad A at Launch Complex 1 at 0630 UTC and has successfully passed through its initial key milestones on its way to payload deployment. The second stage is now ignited and carrying the kick stage with the payload attached the rest of the way into space. At about 10 minutes into the mission, the kick stage will separate and its Curie engine will precisely deliver the payload to its intended orbit.
The shape of an orbit is important. In fact, the entire capstone mission we launched last month is to test the efficiency of the near rectilinear halo orbit, or NRHO, around the Moon. In most Electron missions, our second stage delivers the payload to an elliptical orbit. We then use the Curie engine on the kick stage to circularize that orbit, basically make it circular, to deliver the payload to its new home in space. Quick update, Mission Control is reporting the vehicle is healthy and making good progress onward to deliver its NRO payload.
If you were ever curious, when Electron takes off, it weighs 13 tons, but 90% of that is actually fuel. Electron is so efficient that by the time we reach MECO, it only weighs 1.25 tons. To optimize our weight, we also use a carbon composite shell that in some places is less than 2 millimeters thick. That's thinner than your windows at home. Carbon fiber materials are strong enough to manage the environmental stress from launch while being lighter weight than traditional materials, so we can bring even more payload mass to space for the same fuel. Thank you.
200 seconds to go.
Electron is one of a kind for many reasons, and one is that its engines, all 11 of them, use electric pumps to feed the propellant. Batteries are one of the few items that maintain their weight as they are drained, so once we use them up, we need to get rid of them to keep our flight easy and efficient. This process is called the battery hot swap, and is about to take place as the batteries we started with at liftoff are now depleted. Keep an eye on your screen and that shiny object to the right, as you can often see them falling from the vehicle. But we'll hear the battery hot swap call from Mission Control as well.
Hot swap successful.
Battery jettison confirmed.
There you have it. It happens quick, so hopefully you caught a glimpse as those batteries were ejected from the vehicle. Electron continues nominally through its second stage burn, with kick stage separation coming up in the next few minutes.
AFDS has saved.
The vehicle is continuing well onto orbit, and we're making good progress in our journey to payload deployment. Before, you may have heard Katie talking about how much of the mass of a space rocket is propellant or fuel. But what happens as we use it up? Electron uses most of that fuel in just 8 minutes, which creates a lot of empty space inside the rocket. We actually use helium gas to maintain equilibrium in pressure between the inside and outside of the rocket.
High voltage battery discharge holding nominal.
The views on screen show the glowing red nozzle of our Stage 2 engine. The Rutherford engine on our first stage inspired this second stage, but they operate in fundamentally different environments. Rutherford nozzles are designed with a focus on corrosion resistance and environmental robustness, as it must survive the super high temperatures and pressures during launch. Our second stage engines are designed for space propulsion, so we instead focus on making sure it can cool itself off as it gets extremely hot without convection in the vacuum of space. You can see this happening as it glows red on camera. Both of these engines are 3D printed in our Rocket Lab factory in California, allowing our engineers to easily make small tweaks to make our engines more and more efficient after each flight.
Entered burnout detect mode.
Stage 2 propulsion.
Our next big milestone for Electron is second engine cutoff, or SECO. Just like MECO, or main engine cutoff, the engine on this stage will shut off ahead of the final separation of the second stage from the last or third stage of the vehicle, the kick stage. At this point, the small but mighty Curie engine on the kick stage will carry the payload to its exact destination in space. For this mission, we'll wave goodbye to the kick stage, and to you after SECO and second stage separation.
SECO confirm.
Perfect transfer orbit.
Sweet.
Nominal transfer orbit achieved. Stage 3 separation confirmed.